Hey guys, very good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep, and welcome to the summer special probability and statistics classes. Yes, upskill your level in the probability and statistics, one of the very important topic for every competitive examination. Okay, almost a topic which produces question, yes, almost every time. Okay, sometimes from fundamentals of probability, sometimes from the various distributions, right? Just a moment. Okay, yeah. So quickly, just everybody confirm me whether the audio, video, everything is good at your end. Okay, yeah. So quickly, just everybody confirm me whether the audio, video, everything is good at your end. Okay. Some slight distortion. So quickly, just everybody confirm me. Okay. Alright guys, so let's get moving ahead with continuous random variables. So the past two classes we were talking about discrete distributions, the fundamentals of discrete distributions, what is PMF, mean, variance, all variety of questions from the moderate to the good level of questions. Also we have been talking about the binomial and the Poisson distribution, two very important discrete random variables. Today we'll take up the fundamentals of continuous distributions. Okay. Questions based on PDF, the area under the curve, the mean, variance again here, and then next, like tomorrow, we'll go on to normal distribution and all. Okay, let's get started. This is my introduction. That is all you're aware about. Guys, today, 15th of June, we have also started one special series for you. That is Trickopedia, a dictionary of tricks. Yes, you know, in GATE examinations, eventually you'll need a lot of tricks to simplify your time, to save a lot of time. Okay, and yes, for that, okay, let's trick it. Let's trick it through the series Trickopedia. Okay, so like today morning, you must have seen one video. If not, you can go to the channel again and see. Okay, today morning, early in the morning, there was one video, okay, which I recorded on eigenvalues of 3x3 matrix. Just 5 minutes videos approximately. How to calculate eigenvalues. That 5 minutes video can tell you how to calculate the eigenvalues of 5x5 matrix very quickly. Without property. See, there will be property-based questions also, property-based tricks also that we are going to tell you. Okay, that we are going to tell you. Okay, small videos. But this video, how to calculate directly eigenvalues of a 5x5 matrix very quickly, okay, has been discussed in that video. So just if you want, if you can spare your 5 minutes of time, you'll learn something interesting there. Okay, chalo. Okay guys, so guys, this coming Sunday, that is 18th June at 12 PM on the BYJU'S exam prep app, you get a chance, okay, to take a next step towards your success in GATE examination. Yes, you can avail up to 90% off on the GATE preparation programs. You can get up to 90% off on the GATE preparation exam, okay, to prepare for GATE preparation exam by appearing in the National Scholarship Test. Prove yourself and earn, okay, your respect, earn your rewards. Register now on the app. The first question for you, this is not the question for you, okay, chalo, ye homework answers there, but let me first come up to this one. Let me actually start the class and then, yeah, this is the first question for this. That was actually one of the previous class question that came up here. Okay, the binomial distribution that we have discussed yesterday. Let's come here and let's talk about this. A continuous random variable X has the following probability density function, okay, which we call it as PDF in short. Again, if you have followed the past 3 to 4 classes that I have taken at the same time, you must have understood that in these classes right now at 9 PM, we are focusing on question and its approach, okay, so that you broaden up your thinking. And probability is always about approach and question. It is not a topic where we need to learn a lot of theory and definitions. No, so that is why my approach is through questions. Yes, we are learning everything, but taking up a question. Now, in this question, the PDF is given fx equal to k x raised to the power 1/3 for x is between 0 to 1, and for x less than 0 or greater than 1, the PDF fx is equal to 0. Find the value of k. Right, find the value of k. So what is the important property of PDF you are going to use here? Okay, so all important points will come up in the session through questions. Okay, and different variety of questions you are going to see. What is the important property you are going to use here is this particular property. Integral fx dx for all values of x is always equal to 1. Okay, because integral of the PDF from a to b, integral of the PDF fx dx from a to b gives the probability that the random variable lies between a to b. gives the probability that the random variable lies between a to b. So if I write down integral minus infinity to infinity, it tells us the probability that x is between minus infinity to infinity, and that is the complete sample space. Any variable of the world will of course be between minus infinity to infinity. So this is a sure event. Okay, 100% probability. That is why the probability is 100%, or in absolute form it is equal to 1. Okay, also because PDF talks about the probability density of a particular random variable, it must definitely be positive. Probability per unit length, so it must always be positive because probabilities are always positive. Okay, that is what you must take care. Okay, now there is one more way of putting down this rule. See guys, whenever the function is given, okay, use integral fx dx equal to 1. Okay, use integral fx dx equal to 1. Okay, sometimes the curve of fx may be given. Okay, there you can use area under the curve property. The area under the curve equal to unity. The area under the curve is equal to unity. The area under the curve is equal to the unity. Okay, area under curve equal to unity. Now in this first question, let's start from here. Achha, other than these points, okay, one very simple thing is, like, already you have learned the discrete distribution and you have learned the statistics of it, mean, variance, standard deviation and all those things. All those formula, what is the good part for you with respect to question, all those formula will remain similar. Only thing is summation would be replaced by integration. So yeah, next we will take up the question on mean and variance as well. Expected value, as we have already discussed, expected value means the mean. Okay, so all the formula like E of x for discrete random variable, E of x, what was the formula for discrete random variable? Summation x into PMF. For discrete random variable we talk with respect to PMF. Okay, summation x into PMF. Here it is integral x into PDF. All summation formulas will just replace by the integral. Okay, expected value of x power n, integral x power n fx. Variance, so variance, as we know, it is the expectation of x minus mu whole square. But again guys, summation replaced by integration, that is okay. But what is that I told you for variance, whether it is discrete or continuous? For variance always you will work on this identity, E of x square minus Ex whole square. Okay, for variance always calculated the E of x square minus Ex whole square. Okay, these are again some regular properties. Okay, it is just a review of that. If y is equal to ax plus b, E of y is a E of x plus b. This is a E of x plus b, not ax plus b, a E of x plus b, and variance of y is a square variance of x, right? If PDF of a random variable is even symmetric, okay, even symmetric means f of minus x is equal to fx, then its mean will be 0. It is useful in some of the questions. Then its mean will be 0. Okay, now let's come to the first question and then see how they are going to be useful, right? Okay, the fundamental formulas only, this link. Okay, you will see that, you will understand what are the type of questions and formula coming up. Fx is equal to k x power 1 by 3. Okay, find the value of k. Find the value of k. So what is that formula we are going to use here? Use the formula that integral fx dx is equal to 1. Okay, in general from minus infinity to infinity, but if you see with this question, the limit can be from 0 to 1. Okay, because the random variable is only defined for the range 0 to 1. So integral 0 to 1. Okay, the fx is k, x raised to the power 1 by 3. Okay, the integral fx dx should be equal to 1. Okay, now what is the integral of x power n? X power n plus 1 is divided by n plus 1. Okay, limit 0 to 1. X raised to the power n plus 1 is divided by n plus 1. Okay, is divided by n plus 1. Okay, so now this should be total equal to 1. So hence, okay, just the basic calculation part is left. So 1 by 3 plus 1 will be 4 by 3. So k x power 4 by 3 divide by 4 by 3, limit 0 to 1. This is 1. Okay, so putting down the limit, 4 by 3 when you bring to the numerator becomes 3 by 4. Upper limit 1. 1 power anything is 1. 0 power anything will be 0. So 1 minus 0 is equal to 1. So solving it, the final answer for k is 4 by 3. The final answer for k is 4 by 3. It's a numerical answer type. No options are mentioned. Okay, so k is 4 by 3, or numerical answer type, it should be 1.33 as the final answer. 1.33 as the final answer. That's it. Yeah, correct answer, Shweta. The final answer is 4 by 3. Okay, that is. Guys, is there something blurred with the video suddenly? Hi guys, are you able to see the video? Or is it blurred for you also? I think slightly it is blurred for me. It's blurred. Just a moment. Huh? Yes, hi class. Hi class, is the problem resolved? Is the problem resolved? Now clear. Just a moment. Hi guys. Okay. Yeah, there was some system issues that we were checking on, and that is why maybe my voice was not coming. I hope it should be fine now. Okay guys, I hope it should be fine now. Let's quickly move on. Just a moment. Okay. Now it's fine guys, let's get started, okay, without wasting any other time. There was some inconvenient time that we had visited now. Okay, so this question was done, k is equal to 4/3, that is equal to 1.33. Moving ahead to the next. Okay, now moving ahead to the next here. Okay. So this was some fundamental review. Okay, now next, there are 4 questions based on this one particular question. Okay, given that fx is equal to b by x square, okay, for x is between 1 to 3 and fx is equal to 0 for x less than 1 and x greater than 3. Okay, determine, okay, the value of b, that will make fx a probability density function PDF, and for it to be a PDF, its integral from minus infinity to infinity should be equal to 1. That is very fundamentally clear to us. Okay. Okay, so guys, the first part is similar. The first part is very similar only. So let's start with the first part straight away. Okay, to find the value of b, okay, to find the value of b, we will be using again the integral fx dx is equal to 1 from minus infinity to infinity. But here the random variable is defined for the range 1 to 3. So integral 1 to 3 fx, that is b upon x square dx is equal to 1, right? So b upon x square, what is the integral 1 upon x square? Should be minus 1 by x, limit 1 to 3, and this is total equal to 1. Okay, that means b, okay, that means b, okay, upper limit, yeah, let's take minus outside. Okay, so upper limit will be 1 by 3, lower limit will be equal to 1, and this is equal to 1. Okay, so minus b into minus 2 by 3 is equal to 1. Minus got cancelled, b is equal to 3 by 2 or 1.5. Okay, the value of b is sorted. B is equal to 1.5, dear. The value of b is equal to 1.5. Okay, that is equal to 3 by 2. That is equal to 3 by 2. What is the probability that x is exactly 2? Yes guys, what is the probability that x is exactly equal to 2 for any random variable, for any continuous random variable? See, continuous random variable probability that it can take any value is always 0. Not only for this, probability that random variable can take any particular value, okay, is always 0. Why? Because continuous random variable is defined for a continuous set of values of x. If I say it is defined for all values of x between 1 to 3, yeah, at x equal to 2 it will have some probability density, okay, that is okay, but okay, since it is defined for all values of x between 1 to 3, so how many values are there for x between 1 to 3? It's practically infinite. How many numbers lie between any two real numbers? It is infinite. And out of those infinite, you are looking for a value, probability of one particular value that is equal to 2. So even if you apply the basic law of probability, the basic idea, favorable by total, so you are only looking for one favorable value. Okay, suppose if I say a dice is tossed, what is the probability of getting 2? What is the probability of getting 2? A dice is tossed. So there you will write down that 2 is just one number, but there are total number 6 on the dice. There can be total 6 outcomes on the dice. But how many outcomes are possible here? Here, infinite outcomes are possible. If x is a continuous random variable, that means it can take any real value between 1 to 3, 1, 1.1, 1.2, 1.2222, 1.33, 33765, anything. So total number of values between any two real values is actually infinity, and that is why by the essence of 1 upon infinite, it must be 0. It must be 0. Okay, so what is the probability that x is exactly equal to 2 is 0. And not only 2, probability of any single value in continuous distribution will always be 0. Please remember it. Okay, next find the mean and standard. Standard deviation is root over of variance. Okay, so mean and variance pe work out karte hain. Okay, so let's work out on the next, that is the third one. Okay, there we need to calculate what? Mean, right? So what is the fx now actually? Fx is b upon x square, correct? But what is the value of b? We have found out b is 1.5. Okay, so that is 1.5. Yeah, let me put it like this: 3 by 2 x square for 1 less than x less than 3. B is clear. Okay, now the next part is calculate the mean, mu. That is also known as the expectation, expected value of x. And as I told you, it is integral fx dx. Okay, for all values of x. So this would be equal to integral. Now in general, here for this random variable, it is 1 to 3. So x into the PDF, that is 3 by 2 x square dx is equal to 1, right? So x to x got cancelled. I have 3 by 2. One of the x got cancelled, and then I have integral 1 by x. What should be the integral? 1 upon x. Only 1 upon x is left. Integral 1 upon x is log x. Okay, from the limit 1 to the 3. Okay, isko equal to 1 nahi karna hai, sorry. This is what we are calculating. Okay, so this is equal to 3 by 2 ln 3 minus ln 1. Okay. Okay, ln 3 minus ln 1. The value of log 3 will be 0, only that log 1 will be 0. Okay, what is the value for log 3? That is 1.098 minus log 1. Okay, log 1 to any base is always 0. So final answer is 1.65 approximately. 1.65 is the mean of this random variable. 1.65 is the mean of this random variable. ठीक है जी? Correct है? Yes. Now, the next is standard deviation. Okay, but for standard deviation, let's work out on the variance, and before I start calculating the variance, we should calculate the E of x square, second moment, mean square value. So what is the E of x square? Integral x square fx dx from minus infinity to infinity. Okay, we are aware about all the formulas now. So this becomes integral of x square into 3 by 2 x square dx, right, from limit 1 to 3. This random variable is from limit 1 to 3. So here x square got cancelled. So 3 by 2 outside. Integral of dx is just equal to x, limit 1 to 3. Okay, so 3 by 2, when you solve the upper minus lower limit, that is 2 and cancelled with 3. So it is equal to 3. E of x square is 3. So first of all, what is the variance of this random variable? Variance we know is E of x square minus mean whole square, Ex whole square. Right, so E of x square, it is 3, and the mean obtained was 1.65. We'll just take the square of this and write down the value that is obtained here. Yeah, perfect. So 0.2775. If the variance was asked, it is 0.2775, but they are asking the standard deviation. We know that variance is also represented by sigma square. So standard deviation, that is sigma, it is square root of the variance, and that would be given by approximately 0.53. Approximately 0.53. That is the correct answer for the standard deviation of this distribution. Right? Okay. Okay, cool. Next question. Let's get ready for us. The next question. Okay, as I told you, sometimes the question can be graphical, so it is even more simpler. Okay, if the function is given, you are doing a little bit of integration, but for graphical, it's even more easier. Okay, the graph of a function is given. For fx to be a valid PDF, valid probability density function, for it to be a valid PDF, okay, since curve is given, graph is given, so for valid PDF, you have to use area under the curve is unity. Area under the curve is equal to 1. So it becomes a very simple question now. What is the area under this curve? Okay, this comprises of 3 different rectangular portions, and area of a rectangle we all know is half into base into height. So half, first base is 1, height is equal to h. Okay, right. Next half, for the next triangle also, base is equal to 1, height is given by 2h. For the next rectangle, half, then base is still 1 and height becomes 3h. Okay, this total should be 1, right? So half the common aa gaya, then h plus 2h plus 3h, 6h is equal to 1. Solving it, h is equal to 2 by 6 or 1 by 3. H is equal to 1 by 3, option number A. Simple, sweet. H is equal to 1 by 3. H is equal to the 1 by 3, right? Okay. Okay. Let's take this question first. Okay. A radar telemetry tracking station requires a vast quantity of high quality magnetic tape. Okay. Don't worry, it looks like a drastic difficult language, but question का language जब finally mathematics पे आएगा, it is going to be easy. It has been established that the distance x, okay, between the tape surface flaws has the following probability density function. So they are talking about some distance x, okay, between tape surface flaws, whatever, some variable x is there, उतना ध्यान रखना है, okay, which is 0.005 e power minus 0.005x for x greater than 0, otherwise it is 0. This special distribution, why I am taking this question, First of all, to give you two basic ideas. Number one, okay, sometimes language can be little indirect or lengthy, but the solution will still be simple. Number two is this is a type of special distribution. This is a type of special distribution. Okay, see, this is 0.005. Let's say this is lambda. So this is of the form of lambda e power minus lambda x. Fx is equal to lambda e power minus lambda x for x greater than equal to 0. Only for x greater than 0 is equal to 0. This is also known as an exponential distribution. This is also known as an exponential distribution. This is also known as the exponential distribution. Okay, right? Also known as exponential distribution. Okay, now let me take up some important points here. So as I told you, as I just told you, okay, the fx is lambda e raised to the power minus lambda x for x greater than equal to 0 represents an exponential distribution, right? It represents an exponential distribution, okay, whose curve the PDF curve, okay, is definitely an exponentially decaying function, and it is defined only for x greater than equal to 0, right? For x less than 0, it is 0, right? X equal to 0, e power 0, 1, and this is lambda. So lambda e power minus lambda x for x greater than equal to 0. Lambda e power minus lambda x for x greater than equal to the 0. This is the PDF, and this is defined as an exponential distribution. Now, for this exponential distribution, what is the mean? How do you calculate the mean of this, right? How do you calculate the mean of this? So again, mean means E of x, and that is given by the formula lambda. What is the formula for mean? X into fx. So x into lambda e power minus lambda x dx from 0 to infinity. Here the x is only greater than equal to 0. Okay, so lambda can be taken outside. Lambda can be taken outside. You have the integral x e raised to the power minus lambda x dx. Now very beautifully you have to solve this. How to deal with this? How to deal with this? What you will do is, okay, you will put down lambda into x is equal to t. Lambda into x is equal to t. Okay, just put down the lambda into x is equal to t. So if you put down lambda equal to x equal to t, this integral becomes lambda, right? Integral, if x is equal to 0, t is also 0. If x becomes infinity, t also is infinity. So limit is not affected, but x will be t by lambda, right? X will be t by lambda, e power minus t, e power minus t. What is dx? Okay, what is dx? So lambda dx will be dt. So what is dx? Dx can be written as dt divided by lambda. Okay, one of the lambda will cancel from outside, okay, but one lambda is still left with me. So 1 upon lambda integral t e power minus t dt. Okay, now you must always remember the integration of the form. You must always remember the integration of the form. Integration 0 to infinity x power n minus 1 e power minus x dx. Whether it is in terms of x or t, name of variable inside definite integral does not matter actually. Okay, so we can say integral 0 to infinity x power n minus 1 e power minus x dx is defined as what? Yes, you must be knowing this, engineers, or if you have studied maths already, this is known as the gamma function, right? This is known as the very important gamma function. Okay, this is gamma n. Okay, correct. Abhi, the final answer will be 1 by lambda. This is known as the gamma n function. Okay, now gamma n ke baare mein you must remember two important things. Okay, gamma n plus 1 is n gamma n. Okay, next, right, gamma n plus 1 is equal to factorial n if n is equal to integer. Okay, this first result is valid in general, but second is only for integers. Okay, the second is only for integers. Gamma n plus 1 will be factorial n. Okay, gamma n plus 1 is always n gamma n. That is for any value of n, any positive value of n, but this is only for integral value of n. Okay, so this is what is the gamma function, integral x power n minus 1 e power minus x dx. So isn't it similar? Integral x की जगह t मान लो ना, तो integral x e power minus x, right? So integral x e power minus x, this is like t raised to the power 2 minus 1. It is actually t power 1, but this is t power 2 minus 1 if I have to compare with this, right? So if it is x power 2 minus 1, then it should be gamma 2. Then it should be gamma 2. So what is the answer here? The answer here, dear, is 1 by lambda into gamma 2. And what is the value of gamma 2? What is the value of gamma? N plus 1 is factorial n. और इसको ऐसा भी लिख सकते हैं. So what is gamma n? N minus 1 factorial. Gamma n is n minus 1 factorial. So what is going to be the gamma 2? Gamma 2 is going to be 1 factorial, and 1 factorial is 1. So answer is 1 by lambda. Answer is equal to 1 by lambda. Clear? Answer is equal to 1 by lambda. Okay. Okay. This was e raised to the power. This was e of x, the mean value. This was e of x, the mean value. Okay. Next, if you want to calculate variance, you will be needing e of x square. Variance के लिए क्या चाहिए आपको? For variance, you need the e of x square. And e of x square will be integral x square into PDF, lambda e power minus lambda x dx from 0 to infinity. Again, I will put down lambda x is equal to t. If I put down lambda x is equal to t, देखो एक lambda outside है, limit is unaffected. Okay, x square will become t square by lambda square, e power minus t, and dx will become dt by lambda. So one of the lambda got cancelled. I have still 1 by lambda square outside. Integral 0 to infinity t square e power minus t dt, and this t square can be written as t power 3 minus 1. T power 3 minus 1. So this is equal to 1 by lambda square into gamma 3. Can I say it is gamma 3? Right. And what is the value of gamma 3? The value for gamma 3 is equal to factorial 2. It is factorial 2, and that is equal to 2. So it is 2 by lambda square. So what should be the variance then? We know the variance identity. What is the variance then equal to? The variance in general in this is then given by, okay, e of x square minus ex ka whole square, right? E of x square is 2 by lambda square, mean was 1 by lambda, so 1 by lambda ka whole square, so 2 minus 1, 1. So variance is 1 by lambda square. Variance is 1 by lambda square. So here only let me mention these special formulas, that if you have a exponential random variable, its mean is given by 1 by lambda, its variance is given by 1 by lambda square. Its variance is given by 1 by lambda square. Okay. Also, one more important formula to be remembered, especially for exponential distribution. What is that one more important formula? ये तो gamma function के through solve किया. That one more important case is कि, you know, for exponential random variable, what is the probability that x is greater than a or greater than equal to a? What is the probability that x is greater than equal to a? Right. So probability x greater than equal to a means I'm just telling it can be greater than a. How much greater I have not specified. So it can be even up to infinity. So I can write it as that x is between a to infinity. And to solve it, what is the probability that the variable is between a to b? It should be integral a to b. That is integral a to infinity here of the fx, and fx is lambda e power minus lambda x dx. Okay, so lambda is outside, then I have e power minus lambda x, integral as e power minus lambda x divided by minus lambda, right? Lower limit is equal to the a, upper limit is infinity, lambda to lambda cancel, minus बाहर लग देंगे, e power minus infinity minus e power minus lambda a, but e power minus infinity is 0. Okay, so finally I get minus minus cancel, e power minus lambda a. Okay, one more result, let us mention here that probability x is greater than equal to a. That means, let us say this is some value a. Okay, what is the probability that random variable exceeds a particular value? Okay, and that is e raised to the power minus lambda a. That is e raised to the power minus lambda a. Okay, now collection of all this, let's try to solve this question. Okay, because this is fx is equal to lambda e power minus lambda x, okay, with lambda is equal to 0.005 I can say. Okay, Now suppose one flaw in the tape surface has been identified. Calculate the probability that an additional flaw will be found within the next 100 meter of the tape. Okay, देखो, what is x? Now listen to the question once again. The distance x is the distance between the tape surface flaws. Okay, between the tape surface flaws. केवल language से मुझे मतलब है. Now one flaw has been identified. What is the probability that additional flaw will be found within next 100 meter? मतलब within the next 100 meter. So distance, what does this mean? Distance is less than 100. What is the distance? Less than 100. One is already identified. The additional one is within the next 100 meters. So distance between them is up to the 100. Okay, it is up to the 100. Okay, it is up to the 100. Okay, so what is given to me? Let me rewrite. Fx is 0.005 e power minus 0.005x, which is of the form lambda e power minus lambda x for x greater than equal to 0. What is the first part here? Okay, what is the first part here? Probability that the tape distance is less than 100. Tape distance is less than 100. Acha, what I can do here is, okay, the distance will be either less than 100 or greater than 100. Okay, so what I can do, 1 minus reverse probability. Probability x less than or greater than equal to 100. Okay, reverse. Okay, and how do you find the probability of complement event? 1 minus the probability of the true event. And x greater than equal to a ke liye, I'll just apply this formula, e power minus lambda a. Right, so this is 1 minus e raised to the power minus lambda a formula. So 1 minus e power minus lambda. Lambda is 0.005 and the value of a is 100. So multiplying by 100, it is 1 minus e power minus 0.5. Numerical type value, finally calculating it. 0.39 is the answer. 0.39 is the answer. Right? 0.39. What is the second part? Probability that an additional flaw will not be found at least 200 meter. What does this mean? Probability that the additional flaw will not be found. ये found होगा, okay? Will not be found, okay, for at least 200 meter. Okay, it is not found for at least 200 meters. So wherever it is found, it is after 200 meter. That means one flaw was found, another should be after 200 meters. So what is the distance between the flaws? More than 200. So second question, second part is indirectly telling you what is the probability that x is greater than 200. Okay, so this is equal to again e power minus lambda formula directly. E power minus lambda formula. Okay, so e power minus lambda, lambda is 0.005 and a here is 200. Okay, so if I have to solve this, 0.5 into 2 e power minus 1. E power minus 1 is approximately 0.37. 0.37. Okay, second answer is 0.37. Now, using first and two, maybe we can work out on through. What is the probability that an additional flaw will be found between 100 and 200 meter? Between 100 and 200 meter. Between the 100 and 200 meter. चलो third वाला यहाँ पे करते हैं. What is the probability that, okay, the distance will be between 100 to 200. Will be between 100 to 200. Okay. अब इसके दो तरीके हैं. There are two ways of doing it. Right? Okay. There are two ways of doing it. Number one, okay, probability up to 200 minus probability of 200, or number two, probability A to B. Directly you can use the formula. Na? Probability for random variable between A to B, it is integration A to B. It is integral A to B fx dx. That can also be directly done here. Right? That can also be directly done here. Okay. So this is equal to integral 100, say 200, fx is lambda e power minus lambda x, okay, dx, right? So this will be equal to lambda e power minus lambda x integral is e power minus lambda x upon minus lambda, lower limit 100, upper limit 200. Lambda got cancelled, minus outside लिखा, तो e power minus 200 lambda का value रख लीजिए 0.005 minus e raised to the power minus x की जगह 100, lambda is 0.005. Okay, ठीक है. So how much is this? This is minus of e power minus 1 minus of e power minus 0.5. Okay, or e power minus 0.5 minus e inverse. Let's calculate this value and close the answer. 0.238, approximately 0.24. This is approximately 0.24, right? This is approximately equal to 0.24. Okay, chalo, done hai. Moving ahead to the next then. Okay, moving ahead to the next question then. Chalte hain next question ki taraf. Yeah, now here let me present to you a good question. Okay, a good question from the gate. Okay, so normally we are solving some unique questions, but yeah, it's okay to take one or two good gate questions to be discussed. What is the variance of the random variable with the PDF half mod x e power minus mod x? The PDF is half mod x e raised to the power minus mod x. Half mod x e raised to the power minus mod x. E raised to the power minus mod x. इसको देख लेते हैं. Half mod x e power minus mod x. Okay. ठीक है. Chalo. Now what is the variance? Acha, first of all guys, even if you take f of minus x, because modulus functions are involved, even if you put minus of x, what is the mod of minus x? It is mod x only, na? Okay, inside the mod there is no role of the minus number. I think there is again some issue coming up. Because modulus functions are involved, even if you put minus of x, what is the mod of minus x? It is mod x only, na? Okay, inside the mod there is no role of the minus. Hi. It's actually not the buffering issue, but there is some issue with the video that has again occurred. Okay, chalo, there is some issue with the system itself. Okay, let me quickly discuss this question at least. Okay, otherwise we'll have a lot of time wasted away. So minus mod x is just mod x, so it is half mod x e power minus mod x, and that is just equal to the fx. So f of minus x is just equal to the fx. F of minus x is just equal to the fx, and that simply means that the PDF of this function is even symmetric, and whenever the PDF is even symmetric, the mean value, as I already told you, the mean value will be 0. The mean value is going to be 0 only. The mean will be 0. ये एकदम clear रख लीजिए, ठीक है? So we have to only work on the e of x square. Okay, so e of x square, integral minus infinity to infinity x square fx dx. Acha, one more thing to be noted here is, okay, x square fx dx. Okay, x square fx dx, right? X square is even, fx is also even. Even into even function is a even function, right? So integral minus a to a for even function is twice integral 0 to a. Twice integral 0 to a, first of all, right? Twice integral 0 to a, basic integral property. So now this is equal to twice integral 0 to infinity x square, put down the value, half modulus of x e power minus modulus of x dx. Acha, now dhyan dena, okay, here there is definitely modulus x involved. Here it is the role of modulus x, but if you pay attention, x is between 0 to infinity as per the modified limits. And if x is between 0 to infinity means x is positive. And if x is already positive, what is its modulus value? For positive value, there is no role of modulus. Now, what is modulus of 5? It is 5. What is modulus of 10? It is 10. Okay, so because the limits are positive, ye 2 ko to chalo kiya cancel, I can write down this as integral 0 to infinity x square into x e power minus x. The modulus of x can be written as directly x because x is already positive. X is already positive. Okay, so now this is integral 0 to infinity x cube e power minus x dx. Now, just in today's class, solving one of the earlier question, we revised gamma function. We revised the gamma function, right? This is again of the form x power n minus 1, right? E power minus x, right? So this should be equal to gamma function, gamma n. What is the value of n? n minus 1 is 3, so n is equal to 4. So this is gamma 4 and gamma 4 is factorial 3. Gamma n is factorial n minus 1. So this is equal to 6. Now this is E of x square. The question was variance, but no problem, sir. Variance of x is given by E of x square minus ex whole square, but mean was already 0. So E of x square is 6, mean is 0. So final answer is also 6. The final answer is also equal to the 6. The final answer is also hence equal to the 6. Clear? That is what it is. That is what it is. So why it is a good question? I am telling you. Why I called it as a good question? Because two important points. Okay, you should save the mean calculation here. You can calculate mean again, but you should save it. Time bachana padega. By identifying that PDF is even symmetric, mean is directly 0. Even if you calculate, it will be 0. Second reason why it is good, because somehow it involves the integration, good integration techniques in the form of gamma function. In the form of gamma function, right? In the form of what? In the form of the gamma function. Okay, right. So as always, guys, two homeworks for you for this class. Okay, two homeworks like in the previous classes also I am giving. Please do solve work. I am going to tell you the answer tomorrow, and please do mention the answer, okay, in the comment box as well. F of minus x equal to fx is even symmetric, na Reslik? Okay, homework number 1. Okay, again a random variable is given, find the value of k. And how do you find the value of k? Integral fx dx equal to 1. So some small integration technique you have to apply. Okay, homework number 2 for you. Directly a random variable is given, find the mean and variance. A fundamental question, find the mean and variance. Okay, by the methods that we have discussed. Okay, okay, these are the sessions. Now guys, tomorrow, okay, this is 16th. Tomorrow, okay, 9 p.m. Okay, normal distribution, the very important normal distribution, the very important normal distribution. But Monday and Tuesday, as I have been already telling you, that Monday and Tuesday, yes, there are the mega quizzes on the app. Okay, there is going to be mega quiz on the BYJU'S exam prep app. And why I call it as mega quiz? Because the topper will be rewarded. Okay, based on the cumulative result of both the test, okay, both the quiz, a topper will be given a special reward from our side. Okay, the first quiz is on Monday, discrete random variable, including binomial, Poisson, everything. Okay, that's going to be 5 p.m. on the Monday, 5 p.m. on the app. Okay, this quiz is on the BYJU'S exam prep app. Okay, similarly followed on Tuesday, same time 5 p.m. Okay, there is going to be the quiz on continuous random variable, again on the BYJU'S exam prep app. Okay, continuous random variable, including exponential, normal, whatever we are discussing. Okay, right. So the next one will be Tuesday, continuous random variable. Okay, based on the cumulative results of both, there will be a topper selected to be getting a special reward. Okay, just to motivate you. Okay, so do attend these quizzes on Monday and Tuesday on the BYJU'S exam prep app. Okay, that's it, guys. See you tomorrow with normal distribution. Bye bye. Thank you. Stay safe and take care of yourself.